In this video, we are going to be looking at polygons. Now, polygon is a plane shape bounded by 3 or more straight sides. So a triangle would be a polygon because it's a closed shape and is bounded by 3 sides. So that will be a first polygon, a triangle. Then you'll have a quadrilateral, which is any 4-sided shape. Then you'll have a pentagon, which is a 5-sided shape, a hexagon, which is a 6-sided shape, a heptagon, which has 7 sides, an octagon, which has 8 sides, a nonagon, which has 9 sides, a decagon, which has 10 sides, and so on. Now, the focus of this video is about the interior angles and exterior angles of polygons. So here I have that the sum of the interior angles of an n-sided polygon is equal to 180 multiplied by n take away 2, where n is the number of sides. So a triangle would have 3 sides, so n would be 3 for a triangle. A quadrilateral, which has 4 sides, n would be 4, and so on. And here we have that the sum of the exterior angles of an n-sided polygon is 360 degrees. Now notice the sum of the interior angles depends on the number of sides that you have. Hence the formula 180 times n take away 2. So the value that you would get from this formula would depend on what n is. However, for the sum of the exterior angles of an n-sided polygon, it doesn't matter how many sides you have. It will always be 360 degrees. So when you hear the word regular polygon, whether it be a triangle, quadrilateral, pentagon, hexagon, regular polygon means how much of a sides it have. The sides are equal in length. The interior angles are equal in magnitude. Also, the exterior angles are equal in magnitude. So therefore, an irregular polygon would have sides with different lengths, interior angles with different magnitudes, and exterior angles with different magnitudes. So in my first question, I'm asked to calculate the magnitude of the angle x. I have a polygon here. I have 1, 2, 3, 4, 5 sides. So this is a pentagon. I can see from this diagram that the sides have different lengths. The interior angles have different magnitudes. Therefore, this is an irregular polygon. So here I have that the sum of the interior angles of a 5-sided polygon is equal to 180 times 5 take away 2. So if we recall that the sum of the interior angles of an n-sided polygon is equal to 180 times n take away 2. So n is the number of sides. So in my question, I have a 5-sided shape, therefore n is 5. So this will be equal to 180 times 5 take away 2, which is 3. And that will give 540 degrees. So now I know that all 5 interior angles would add up to 540 degrees. So that means x plus 30 degrees plus 120 degrees plus 95 degrees plus 130 degrees is equal to 540 degrees. Alright, so that's my x plus 30 degrees plus 120 degrees plus 95 degrees plus 130 degrees is equal to 540 degrees. So now I'll add up these angles here and I'll get x plus 375 degrees is equal to 540 degrees. So now I'll just transfer this positive 375 degrees, cross the equal sign, and I'll have x is equal to 540 degrees, take away 375 degrees. So the sign in front of the 375 was positive, so when I transfer it across to the right hand side, the sign in front of it turned to negative. So I'll have x is equal to 165 degrees. So here I have my second question, where I want to calculate the magnitude of the angle x. Now x is one of the exterior angles. I have the other 2 exterior angles here, 90 and 100. Now this is a triangle, and we know that the sum of the interior angles of a triangle is 180 degrees. But we are dealing with the exterior angles here, and the sum of the exterior angles will be 360 degrees. It doesn't matter how many sides we have. The sum of the exterior angles of any polygon would be 360 degrees. So what we'll have is x plus 90 degrees plus 100 degrees would equal to 360 degrees. So now I'll add up the 90 and the 100, and I'll get x plus 190 degrees is equal to 360 degrees. So now I'll just transfer this positive 190 degrees across to the right hand side, and we'll turn to negative 190 degrees. So I'll have x is equal to 360 degrees, take away 190 degrees. So x will be equal to 170 degrees. So in my third question here, I want to find the magnitude of each interior angle of a regular hexagon. So regular would mean that the hexagon, the lengths of its sides are equal, the interior angles have equal magnitude, also the exterior angles has equal magnitude. So a hexagon has 6 sides, so we have 1, 2, 3, 4, 5, 6 sides. Each side has equal length, and each interior angle would have the same magnitude. So I can call each interior angle x. So first I'll need to know what is the sum of the interior angles of this hexagon. So I have my formula for the sum of the interior angles as 180 times n take away 2, where n is the number of sides. And this hexagon has 6 sides. So I'll have my n being equal to 6. So now 6 take away 2 is 4. So I'll have 180 times 4. So that will give 720 degrees. So now I know these 6 interior angles must add up to 720 degrees. So I'll have to add up these 6 x's, which are the interior angles of the hexagon, and that will give 6x. So I'll have x plus x is 2x, plus x is 3x, plus x is 4x, plus x is 5x, plus this x is 6x. So I'll have 6x is equal to 720 degrees. So x is equal to 720 degrees divided by 6. So x is equal to 120 degrees. So here in my fourth question, I want to calculate the magnitude of each exterior angle of a regular pentagon. So a pentagon has 5 sides, 1, 2, 3, 4, 5. And we know that the sum of the exterior angles of any polygon would be 360 degrees. So since the pentagon is regular, each exterior angle would have the same magnitude. So I can call each exterior angle x. So I know that all these x's must add up to be 360 degrees because that's the sum of the exterior angles. So I have x plus x is 2x, plus x is 3x, plus x is 4x, plus x is 5x. So I have 5x is equal to 360 degrees. So x is equal to 360 degrees divided by 5. So x is equal to 72 degrees.